Hello everybody, welcome back to another live stream. Alright, well, let me share the live. Please make sure to join in on the server so you can get notified about live streams, and also you can participate in some polls about which topic we're choosing for the live stream basically. So let me share the link. Right, my server, there you go, and there you go. Nice streams. All right. Alright. Alrighty. Gotta sip some coffee. Are you using mach-gpu-dawn library or something else? If you watched my previous live stream, I tried to use Mac first of all, but it failed horribly for whatever reason. So I tried zig-gamedev and it worked perfectly for me. And yeah, so I'm using zig-gamedev library for that. It's pretty much the same thing, just different binding. But I really loved using zig-gamedev so far. It basically gives you everything you need to start off. It gives you a math library, it gives you GFW, it gives you GPU, which is basically WGPU binding or WebGPU binding for Dawn, and also all sorts of things. Yeah, Mac seemed large and I didn't know how to slice out just the GPU thing. No, there's actually a repo for the GPU thing by itself. I mean, it's called mach-gpu, I guess. So there you go. It's called, there you go. Here it is. It's called mach-gpu-dawn. This is the binding by Mac, but it didn't work for me. Or at least I couldn't get it to work for me last live stream. But I tried zig-gamedev and it worked perfectly. And there's also another one though from Mac, which is this guy, which I think is basically another layer on top of the first repo that I sent. It's basically, there you go. So let me just read it for you. Provides a truly cross-platform graphics API for Zig, desktop, mobile, and web with unified low-level graphics and compute backed by Vulkan Metal D3, D12, and OpenGL as a best efforts fallback. And open, okay. So yeah, pretty much. And here's the second one. Although I couldn't get it to work, honestly. But honestly, I tried a lot of times. I kind of tried to use Mac libraries, but I always end up, well, not always, but most of the time it end up not working for whatever reason. It seems like Mac's project is not very stable. There is probably a lot of changes going on, especially with Zig constantly releasing breaking changes. And since Mac have a quite a kind of a big project, so it's kind of, I do expect that it takes them some time to go through all the projects and fix them basically. So yeah, but I'm using zig-gamedev though. That worked for me perfectly, flawlessly, at least until now. So yeah, there you go. This one worked for me perfectly. And also it has samples, it has all sorts of libraries that you may want basically. Yeah, only stabilize once Zig stabilizes, which is a year plus time. Yeah, pretty much. But Zig pretty much is not that stable, but at least you need to get something working, you know. So yeah, I think we probably would start right now at this point, so we don't waste time. I just like to delay the stream just a bit. for people that are interested to join in. It's already been 5 minutes. I'm not sure. Let me know if you want me to delay it for around another 5 minutes, or should we start now? What do you think? Right. So pretty much going to continue our adventure of yesterday. We have done quite a lot yesterday though. It's been around like 3 hours, I think, if I remember well. But yeah, that was pretty fun. So yeah, all right. So what do you think we should do today? I do have some ideas, but just let me know your ideas. So far we just got a triangle, I think, on the screen. Hold on. Let me show you what we got so far from yesterday's stream. Of course, let me remind you again, I'm learning live. Basically, I do not have previous experience with WGPU. I do have a little bit of experience, kind of, but nothing really serious, you know. Never really seriously tried to learn it. But there you go, we just had a little triangle, and then we have the background being colored using, what is it called, ZGY, using basically Dear EMGY. And yeah, that's basically what we got. Let me know what you want me to do next. I do have some ideas, as I said, but let me know. So I can consider it if it seems easy enough. Also, text drawing is fun to implement always. Yeah, I'd very much like to actually implement text rendering, but I think that's gonna be a little bit complex for me for now. So we're gonna take it easy. So we started by basically, in fact, let me have a look. Hold on a second. Let me see if I can find it here. I just installed some extensions, but I'm not sure yet how to use them. There you go. Okay, so the first stage that we have tried to basically implement is just getting rendering on. Basically rendering nothing, but you are rendering. So this is what it took, like around 33 lines of code, and we were able to basically just get the texture of the swap chain, create a command buffer, or it's called a command encoder, and basically you finish the command buffer, then you submit it to the GPU so it can basically execute it, and then you present the swap chain. As simple as that. That was the first stage. The second stage that we tried is an animated colored window. And here where we actually got something rendering instead of just nothing rendering. And this is what we have added. We basically begun a render pass, and I actually used the helper function called begin render pass simple, which really cut down on code a bit. And there you go, encoder, blah blah blah. And I used the time to kind of animate it a bit there. And yeah, that's pretty much it. And that was giving us a colored background basically. And next up we got ZGY color picker. Here where I actually set it up ZGY, which is basically a binding to Dear AMGY. This part was a lot of fun because I never used a Dear MGY before. I always have seen it, but I never got the chance to use it. But last live stream I had a lot of fun with it. It's very, very powerful, honestly. So that was the code that I have to add to actually make it work. Pretty simple. And of course I added the font. And finally the other one is a triangle. So we added the shaders, basically the shader source. Then we added the pipeline stuff, basically created a pipeline. And this is all the stuff that is needed for a pipeline. And then the matrices stuff for transformations. And yeah, pretty much. And of course the bind groups, etc. And that was pretty much it. And of course the buffers, right? that's pretty much it. And finally, the last one that I've done off camera, which is nothing really. I just added some licenses and some readme and some other stuff. Nothing really serious though. I just changed, let me see, I just changed the path of the Roboto medium font. And yeah, that's pretty much it. And I added some files there. Pretty much. So yeah, let's get going. I think at this point, let's get going. So right here, I have just a sample that I'm always referencing to see how they doing stuff, and I'm trying to implement stuff in. Okay, so you could just do the search into a texture. Oh yeah, per quad index texture coordinate letter on screen. Yeah, I see what you mean. A simple thing would be a FPS etc. performance metric display with MGY. Yeah, I see. All right, so I think let's get started. I do have some ideas in mind already. I think the first thing that I'd like to do though, which is to basically make one module instead of two separate modules. Why not just combine those two together in one source code basically? So this is what I'm going to try to do. I think it's pretty simple. I'm just gonna take this guy, put it together. Oopsies, let me make sure that's right. And now I'm gonna call this shader source instead of vertex shader. Okay, and now let me try. Now we only need one shader module. There is not a difference so far. At least I cannot really think of a difference between these two methods, but I just like to demonstrate that this is possible first of all, and second of all, I kind of prefer this way of doing it. So yeah, pretty much. Alright, so let's keep going. Where I was, let's see. Okay, let me see what I've done so far. Shader source. Okay, interesting. So let's go to the shader modules. So I only need one shader module right now using this method. There you go. I'm gonna call it shader module. Let me know if you know of a difference between these two methods, but there you go. Fragment shader module and shader module. And here I'm just gonna call this shader module. Of course, this is just a label for debugging purposes. You can call this whatever you want. So yeah, shader shader source. There you go. So that was it for that one. Let me see. Next up is here. I gotta change it here. All right, back. Okay, right now I got distracted once again. Oh my god. Now I lost track once again. Okay, fine, gotcha. So shader module, where I should change it again. Let me see. Let me search where I'm using that guy. Okay, I changed that one. Nice. We do need two things because we have a vertex and a fragment. And yeah, I think that's pretty much it. Although we're gonna have a little error. I did try this before. We're gonna have a little error, but I wanted to show you the error so you're mindful of it. There you go. So here's what it says. So WGPU errors are pretty good, honestly. While WebGL, for example, would just tell you invalid operation. That's it. I had a meme here. Hold on, let me see if I can find it. I posted it on my server. Well, where is it? Where is it? There you go. There you go. All right. So this is some Vulkan code. Here's how much it takes to make a triangle in Vulkan. This whole code. And OpenGL 3 plus, this is the code that it needed. And OpenGL 1.x, this is the code that it needed. And DX12, DirectX 12, which is kind of like Vulkan, but you know, for Windows. And this is the code that is required. Almost near Vulkan, but Vulkan is bigger. And DX11, that's the code that is needed. DX9, it seems like it's just growing and growing. Because basically the code of the driver is becoming the code of the actual developer through time, because we're trying to get more performance out of the GPU and more control. That's basically what's happening. So, and here's the second meme. So, hey, and of course I came from this with a talk. This is the talk that I got these from. Introduction to WebGPU. But anyway, so hey WebGL, what went wrong here? Here's WebGL. So when an error happens, it just tells you GL invalid operation. That's it. Thanks WebGL. Oh my god, soon pass that on to the user to have optimal performance settings. Shown mistakes. Yeah. All right. So yeah. But let's see let's try to dissect the error here. I already got through this error, but anyway. Validation tint WGSL reader failure 1513. So it tells you the line and the column, I think. And then the error is redeclaration of main. There you go. It says that it's basically pointing to fragment fn main and vertex fn main. So it's basically telling me that I declared main 2 times, and that makes total sense. So I have to basically call one of them differently, basically. So honestly, I'm going to, this is just a preference. You can call them whatever you want. For the vertex, I'm just going to call it vertex, honestly. For fragment, I'm going to call it fragment. Pretty simple. But of course, after that, I had to do another change. But let me just see what's the error that it's going to give me. Because really, trying to understand the errors is very, very useful for beginners. But anyway, so validation, entry point main doesn't exist in the shader module. So it's telling us that the entry point main doesn't exist. Why? If we go back to where we're using that guy, there you go. Here we say the entry point. Now in vertex, I have to tell it what is the entry point function to the vertex. So to the vertex function, and I called it vertex, so I need to call it vertex here, and here I should call it fragment, and that should work out just fine. Just like before, I tried to research like what's the difference between these two methods, but I couldn't find any difference, honestly. So, but if anyone knows, let me know in the comments or whatever. So yeah, pretty much interesting. Now, next up, I'd like to, instead of embed the source code directly inline in my code, I'd like to embed it from a file, okay? So you're gonna create a file. I also tried this off camera. Where is it? Where is it? Okay, so in assets, I'm gonna create a new folder. So I basically create an assets folder off camera, which I put in SRC. Seems like, oh, really? SRC? I think maybe it didn't reset my changes. Hold on a second. If I go to github.com, hold on a second, let me recheck one little thing so I don't confuse anyone. WGPU? Sorry, WGPU, okay. WGPU, all right. Let's go, and where is it? Oh yeah, I actually have assets right here, but somehow it didn't actually reset my changes. But anyway, basically just make sure that, oh, what the? Okay, let me just remove this guy, okay? It seems like it didn't reset it. Okay, amazing. So pretend you didn't see that. All right, so we're gonna get the assets folder here. I'm gonna basically take it into the SRC. Or honestly, let me show you why I need to do that. But let's just go ahead and do the stuff that we wanted to do. So shader.wgsl. Okay. And now instead, and by the way, someone have asked about extensions though. This is the extensions that I have. C++ stuff. So I'm just gonna scroll here. Pretty much error lens, framer dark, git graph. And this is the extension that I just installed, yes, like off camera after the previous live stream. I just searched for some extensions for WGSL and that showed up, so I just installed it so I can have some syntax highlighting in my shader basically. But the most important extensions, at least for this project, is basically ZLS, which is basically the Zig LSP. It's called Zig language, I guess, here. There you go. It's called Zig language. That's the first one. And the other one that I like to use is Airlines. And the other one, where is it? Let's see. I think code LLDB. I think code no, I actually use C++. You need this for debugging. I'm going to show you how to debug Zig code later on, I think. There's Framer Dark. This is for the theme that I'm using here. GitHub stuff, that's pretty useful. I think you may like GitLens. It basically shows you who done the changes. But anyway, VS Code icons, just for better icons. And yeah, that's pretty much it. And also, just for completeness, I'm going to show you also the settings. I like to always turn on mouse wheel zoom, so I could basically hold control and then zoom with my mouse wheel. I don't know why that's not enabled by default. That's just so stupid, but I don't know. I guess that's weird. Anyway, and then also I like to always have format on save always on, and it's in fact here modified elsewhere. It's modified probably in Zig or something. But anyway, basically I always enable that too. So basically when I save, it will always try to format my code. VS Code has extension profiles, which is useful when you use many different languages and learn speed. Oh, that's interesting. I never really thought about that. But honestly, it's like VS Code is still not that slow yet, so I didn't really search for it. But anyway, so let's just go further. Alright, so I'm just going to copy this shader code. I'm going to put it here, and of course I'm going to remove this, guys. And I'm just gonna press there, hold Alt and Shift, and there you go. And you could basically box select, basically, and you're gonna have all these cursors, and then you can remove them. And there you go, done. Done. Let me just format this a bit. Okay, and yeah, that's pretty much it. And now here's how I can embed it. Now instead of this stuff, and I don't need Zig FMT off and on anymore, and instead of this stuff I could just say embed file, and then here you can give it the path. In my case, the path is asset/shaders, I believe, /shader.wgsl. Now we're gonna have a little error here, and I'll show you why. Which is that enable to open asset/shader/shader.wgsl file not found. And that's because you cannot use embed file for files that aren't inside of your source directory. There is some way to actually change that and make that possible, I think, through build.zig, but I don't know. There's no need, I guess, for it, really. So I'm just gonna make sure to put my assets folder in SRC and call it a day, basically. And yeah, move it all on. And what have happened? Oh, what I've done? Weird. Oh, it only got Roboto. Let me get the whole assets folder. and put it inside src, move. And let me make sure to put in a folder called shaders, I guess. And then I could put that guy there, move it. Then also let me move in, make a new folder called fonts. Why not? And let's put Roboto there. I don't know why that's, oh my, well, that's so annoying. Let me put that guy there, move it on to assets, and move the shaders to assets. That kind of confused me for a second there. And the license is for Roboto. And the Roboto, I'm gonna put it in fonts, move. And yeah, so we gotta change some path right here. I basically gotta change the font path. Where is it? Hold on. Roboto. There you go. But for whatever reason, it seems like add fonts from file actually takes files from the root directory, not the actual source directory. So I'm going to make sure to say src/assets/fonts, since I added that folder there, /roboto, and that should work out just fine. Hopefully, let's see. And there we go, works just like before. Now, the thing is, you could basically load shader source code either in runtime or at runtime or at compile time. In my case, I'm using embed file, which is basically embedding the source code of the shader into my own program, into the binary, so at compile time. But you can indeed go ahead and do that at runtime. Now the catch here, when you actually embed your shader source code at compile time like this, is that whenever you change your shader, you have to recompile your program, which could be quite bad for when you have a bigger program. So it will take much longer time to compile. So then you probably want to load the shaders at runtime. But anyway, and also another thing is that on some platforms you may have problems with the file system. So you'd probably better off just embedding it at compile time and call it a day. But anyway, I think that's pretty clear so far. Now, that's pretty much what I've done off camera, but I resetted it so I can show you. So yeah, hot reload these shaders is good for fiddling with them. It's pretty much a must for myself. Yeah, pretty much. But so far, I think my program is small enough that it doesn't really pose an issue. But anyway. Although I guess you could just use Shader Toy. Yeah, but Shader Toy uses GLSL though. And anyway, vertex out. So, okay, what I want to do next. I think what I want to show you next though, or what I want to try next, is to basically create a index buffer. Hold on a second. How to create a second buffer, which is an index buffer. So let's find out how we can do that. I'm going to try to figure out on my own without looking into the sample, hopefully, but we'll see how it goes. So let's see, I guess. Let's try it out. Honestly, I'd better off just looking into the sample instead of wasting time. But yeah. Bind group mem.offset. Okay, so let's see how it's doing it. So if we go to the buffer stuff, buffer, so that's the vertex buffer, and there you go, that's the index buffer. So I think it's pretty much the same. One thing that, and by the way, there is a copy destination. DST means destination, and this flag is on. I know this from Vulkan. But this flag is on because we're using the command write buffer, which basically copies over the data that we have here from the CPU side, I think, to the GPU side, basically. And that's why you need to tell it that this is meant as a copy destination, because you're going to copy something to it. So yeah, because this is an actual command that gets executed in the GPU to basically write to the buffer the data that we have. So yeah, now basically the same thing for index buffer. You have copy DST because we want to write some data later on it. But instead of activating the vertex flag or property, we're activating the index instead, because this is meant to be an index buffer. This is kind of like usage flags. I mean, at least in Vulkan they're called usage flags though. But anyway, so here the size is, in this case, 3 times size of vertex. And it's 3 because, well, we have 3 vertices. And size of course, we're taking the size of the vertex struct. So honestly, why not? I don't know why he didn't do it, but basically you could put the vertex data here. But I don't want to change, of course, that's not my code, that's just the sample. But I'd probably honestly change it in my own code. Hold on a second. Let me see. There you go. So here you go. So why not actually put the vertex data? Am I missing something here? But maybe put the vertex data first. Then here basically take the vertex data dot len. So get the length. So when I add another vertex here, I don't have to worry about changing it here too. So that's pretty much it for that one, I guess. Let me just make sure this at least works. Amazing. I could do another kind of weird thing that Zig allows me to do, which is basically when you have, for example, an array or a pointer, you can get the type, the child type of that type. For example, the type here is an array, right? An array of vertex. Now, I can get vertex. I can get basically the type of the elements of the array. And you can actually get that, if I remember well, I didn't do that for a long time. I think std.meta.getChild. Like Zig, like comp time stuff and meta programming is very wild. You can do all sorts of crazy things. And later on, I'm going to try to basically automate this task of describing the vertex properties later on, because there's a lot of repetitive stuff there. But anyways, where is it? I do not really remember. Yeah, there you go. I think this is the one. std.meta.child. So as you can see, given a parameterized type array vector, pointer optional returns the child type. Okay, let me try this out. So instead of size of vertex, you could basically say size of, child of, size of child of vertex data, I believe. Isn't it? I think so. Let me see. So expected type found 3 main. Oh yeah, I should actually give it the type, not the, so I should say basically type of. So this is some pretty wild stuff. So type of, okay. So I need to get the type of the array instead of the array itself. And there you go. So basically right now I can easily change if I change here the vertex to whatever another struct, I do not have to change it here too once again, basically. And the same thing I believe in here. But honestly, there's no need currently. Let us just keep it like that. This is just a fun thing that we may do later. But let's just keep it readable for now. So yeah. So what I wanted other than that, let's see where we have a 3. There you go. For example, here we're drawing and we're telling it how much vertices we want to draw, the vertex count. So we could basically also here say vertex data.len. So yeah, pretty much. Also, one other thing that I missed the last live stream or the previous live stream is that the sample was using a time here, so to do an animation, but I didn't really wanted to do that before. I would have started extracting this into useful functions, but I'm not sure about the zig workflow. It works in C# though. Yeah, I would have done that, but I'm trying to stay away from abstracting stuff, because once you start abstracting, you go into a, like, I don't know what to call it. But basically, once you start, you never end. So I just like to not waste time currently on abstractions. I'd like to just write everything in the main function for now. So yeah, abstract bot mode. Exactly. So yep, I'd like to keep stuff simple for now. Okay, what I wanted once again, I forgot. Oh yeah, the sample time. Where is it? So let me see here in the sample. It was a rotate Y. What? Oh yeah, I see. Rotate. There you go. Rotation Y, and it's using this T value. Let me see what T is. So it's basically using graphics context stats time. Ooh, so interesting. Okay. Where is it putting it? Yeah, and the first before drawing. Well, where I'm going to put it, I think here maybe. I mean, I don't think it matters, but yeah. Graphics context dot stats dot time, and then I could use that time value, and honestly, let us call it time. Is it in seconds or what exactly? Not sure. Probably in seconds. Delta time. I would guess in seconds, but I have no idea. Oh yeah, it's using GFW get time. So that makes sense. And I do not remember if GFW get time gives you in seconds or otherwise. Probably in seconds. Come on, why the internet's so slow? No idea. Okay. So it returns the value of the GFW timer unless the timer has been set using oh yeah, the current value in seconds, or 0 if an error occurred. Okay, nice. So it's in seconds, pretty much. Interesting. So we have here time in seconds. So seconds elapsed, basically. And then I could use that to make animations. Let me see. So I'm basically passing it to that rotation Y. And let's see what's gonna happen. I have no idea, didn't try this before. What? Alright, we got a rotating triangle because basically we're using time. That's why it's animating right now, it's rotating. And by the way, notice that it's not drawing one triangle though. We're not drawing only one triangle. We're drawing two triangles because we're not calling the triangle. And let me show you where we are doing that guy. Hold on a second. Where we're creating the pipeline. Thankfully I learned this stuff from Vulkan. So where is it? Where is it? I guess it's probably in here somewhere. I do not. Probably maybe fragment. No. Hold on. Let me go to the render pipeline descriptor and let's find out. So label layout vertex state or primitive, probably primitive state, right? There you go. Yeah, primitive state. But why it didn't show me that in? So it's called primitive. Okay. So basically add dot primitive is equal to, and let's see, so call mode, there you go. Call mode by default is none, which means it doesn't do any calling. And also you can set the front face, but I just recommend keeping it as default unless if you really need to. There's also topology. I also recommend keeping it as default. And there's also strip index format, which is quite interesting, but it's interesting for other topologies, but you won't need that for triangle-less topology. I could show you that later on if you want to. But anyway, call mode is equal to, okay, well, what is the type of that guy? Really? It's call mode. ZLS is not working properly. Let me try to restart it and hopefully it would help me now. Nope. Okay, let me do the manual work. Multi-sem primitive state, there you go, and call mode. Okay, so there's none, front and back. Which one you want to call? Let's try to call the back face. And let's see what's gonna happen there. Let me add the trailing comma. And let's go. And notice when it's rotating, once it's on the other side, you do not see any triangle because it's called. It only shows one triangle. And that's very useful because when you have a mesh, you know, like a cube, for example, you don't want to draw the inner triangles, the inner faces of the cube. You only want to draw and to waste computation and the GPU time on the actual things that really the users see, basically. So that's why I'm going to keep the call mode for now. And also it's nice to keep it on. So if there's anything weird with your calculation, you can notice it at the right time. Otherwise, if you don't see your triangle, then maybe try to put this into none and see if that's the problem. But anyway, for now, I'm just gonna keep it like that. That's nice. Okay, so other than that, what we have next? I think I wanted to add the buffer, right? Let me try to think. I didn't have a look into the mathematics yet though. But let's just try to add another buffer, the index buffer, by the way. So let's go ahead and try to do that. Okay, let's go back to the sample that we have. Okay, where it's creating the index buffer, there you go. So basically we need this code right here. So it's creating a buffer. I'm going to try to not copy it, I guess. Let me try, let's see. So I can actually learn how it's done. Anyway, const index buffer is equal to graphics context dot create buffer. Okay, it's expecting the descriptor. Now the usage, why it's not showing me that guy? Anyway, and we need the copy_dst equal to true, and we also need the the index equal to true. That's the usage flag, right? And the size is basically equal to not vertex indices though. Just got home. Hello Doom White, welcome to the live stream. How's it going? It's going pretty well. Let me show you what we have done so far. We got a triangle rotating. There you go. But let me actually make the call mode none for a second there. And that's what we got. Rotating triangle. Interestingly. Lovely. Okay, so let's go back to back call mode and let's grab that back. Also, I extracted the shader into an actual file, basically. So yeah, that's pretty much what we have done so far, I think. And here, size. Size, I honestly do not remember. So first of all, in fact, we need the index data. So it's an array of U32s. So const index data is equal to an array, and this basically means that we want Zig to infer the array size. And basically 1, 2, 3, cool stuff. I'll follow this out from the start. Yeah, thanks. Okay, U32. Now we're gonna say index data, I guess, dot size or dot len. I mean, do we need something else? Where we are, times size of U30. Yeah, like that. Times size of U32. Amazing, 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 amazing. So what's next? So this is basically the size, I think, in bytes. That's why we need all that stuff. I'm not sure if there is a way to actually get the size of the array directly, I guess, instead of doing it this way, but anyway. Okay, so what else? And also, of course, right now we have to instruct the GPU to write to the buffer, because we have the data on the CPU side, and I think the index buffer probably maybe on the GPU memory. So we have to tell the GPU to basically copy data from our side to its side. Can you use size of in the array itself? Arrays, I mean, actually, good question. Good question. I think you can, maybe. Like, why the sample are doing it this way, though? Why they're doing it this way? I guess so it's clear that you can basically change the how much indices you want to use from the index buffer, so not necessarily that, I guess. I mean, yeah, sure, but let me try to figure out how to work with an index buffer first, I guess. But honestly, you know what? That's let me try it. Let's see. Where is it? There you go. Let me see if this works, by the way, just for a second before breaking something. Just making sure. Okay, so right now, as you can see, it's working. Nice. Now let me try it out. So instead of that guy, I can say size of vertex data. Oh, I need to give it the type. So let me give it the type of data, of the vertex data. Okay, let me try that out. And I think it works. Yeah, it works. Lovely. Let's go. Although you need to add that type of, because you cannot give the vertex data value, you know, you need to give it the type of the vertex data. That's why you use type of here. So yeah, pretty much. Nice. So I could basically use that right now. I trust that more than I would in C#. Okay, size of. Okay, here type of, I guess. Type of index data. Amazing. I'm not sure why the sample didn't use such a thing, but I guess maybe they're trying to not use advanced Zig features. I mean, this could be kind of confusing for new people, for beginners, I think. Maybe the array with that size is a type itself. Yeah, I mean, it's a type. The type is basically three U32s. It's basically a type. So when you say type of something, it gets the type of that value at compile time. That's like Zig comp time stuff is just amazing. I still didn't really show you the actual power of Zig. I'm just trying to go slowly right here and trying to learn the basics first. So anyway, amazing. So now let's actually tell the graphics the queue. We're gonna add the command there. We're gonna tell it to copy, or what it was called. I do not remember. I think write buffer, I guess. And the queue, I've already gave it that. So you give it the buffer, which is in this case the index buffer, then you give it the offset, which I think is probably 0. But basically this offset could be used for, basically you could, instead of creating 2 buffers, for example, you could create 1 buffer, but then have 1 slice of the buffer used for indices, and then, for example, another slice of the buffer used for something else. This could be an optimization, I guess. But anyway, comp time t type, staged buffer updates. I don't know what it's called exactly, but anyway, comp time t type. Let's see. The type is U32. Well, the child, again, you could say U32, but you could use another cool feature of Zig, which is, I already have shown that before, which is basically a cd.meta.child, but you have to say type of index buffer, index data. And then here the actual data, which is index data. But honestly, I don't know if I want to. I guess let me just keep it as U32, so if anyone is reading my code, they can understand what I'm doing. So I'm too lazy to link the definition of staged. Let me actually search here. Hold on a second. Google nowadays is weird, so. Nah, couldn't find anything about it, honestly. Like, couldn't find anything related to graphics. But anyway. So I think that's pretty much it. Now we got the index buffer going on. Now we need to use it though. Now the first thing that I can remember that I need to do to be able to use the index buffer is to actually, instead of using a draw, I need to use draw indexed. There's also indirect, which is quite interesting, but that's a bit advanced. And I never really tried it. I just know what it is, kind of. But anyway, index count. So here we could say indices. Well, what I called it though, index data. Indices actually. Okay, well, I think I've seen the word used in having 2 buffers in the same space, but they're true. It's probably staged buffer. That's what I've heard, not staged, but yeah. Interwoven. Not sure. Anyway, so index buffer dot len. What? Hold on. And in fact, I don't want to call it index data. Indices. Indices. Honestly, just keep it, bruh. Just keep it. Just keep it. Anyway, who cares? Alright. What Zig version is that? The latest, pretty much. Not the stable one though, because the stable one doesn't work with the ZLS, the LSP. So index data.len. There you go. Instance count, instances. I'm just gonna be using 1. That could be used for instancing. I can show you instancing later on. Yeah, 0.11 is coming towards August. August. So first index 0, base vertex I think 0. First instance 0. Okay. I probably need to do something else. Oh yeah, I need to set it here though. I need to set it here. Set index buffer. And I need to give it the buffer. The index format, which is U32 if I remember, and the offset is 0, and the size is indices index data.len. And I think that's pretty much it. Use of declared the index buffer. And I guess that's it. Let's see if that works. Expected type WGPU buffer opaque. Oh yeah, I think I probably need to actually do this guy right here. So index buffer info. Okay, look up resource info, index buffer. Oopsies. Index buffer. Alright, index buffer info. Now instead of that buffer, I think I need to use that one. Where is it? Where is it? Where is it? There you go. So maybe index buffer info. Maybe .gpu obj though. But let me try that first. Yeah, probably GPU obj, just like we have done here. Yeah, I think so. .gpu obj, and then you do that trick. Anyways. And my coffee is done. And I think that didn't work. Isn't it? Yeah, it didn't. Why? Let me see how they have done it in the sample. Oh, wait, hold on. Where that error is coming from? Oh my, gotcha. Well, in fact, it's talking about this guy. And for this guy, I actually gotta do lookup resource, not the index buffer itself. And then you give it the handle. So index buffer is pretty much just a handle, really. But anyway, let me try if that works now. What does the point question mark do? Don't remember that syntax. So if you got an optional, basically, you could basically unwrap it using that syntax. It's kind of like, I don't know, remember how they do it in Rust. Bruh. Couldn't even remember how they do it in Rust. Unwrap? I think unwrap, right? Yeah, probably unwrap. Probably unwrap. So yeah, it's pretty much similar to that if you know Rust. Now what's going on here? Consider using yeah, I need to use that guy. But basically lookup resource gives you an optional, as you can see, and we basically kind of unwrapping it. Array literal requires address of operator to coerce to a slice. Oh yeah, that takes a slice, but we have an array here, so to turn it to a slice we could take the address off to coerce it to a slice. Alright, what's next? What's the other problem? Expected type WGPU index format found type. Well, interesting. So weird, that's basically an error that you're not handling. Yeah, pretty much. Like this is indefined behavior in release mode, but I'm just using it right now. So yeah. Where is it right now? It's basically looking for some stupid index format. Let me see. So WGPU.index format. Oh, zgpu.wgpu.index format dot. There you go. You enter 2. Let's see if that works. Come on. Expected type found WGPU index format. Well, you have just told me that. What? That is so stupid. Well, let me see how they have done it here. Right buffer? I mean, they're doing here U32, so I do not know. I mean, hold on. Let me actually copy this code and see what they're doing exactly. So right buffer, I'm doing the exact same thing. Graphics context lookup resource index buffer dot that guy, comma 0, comma U32, index data. But why that didn't work out? I don't understand that. Interleaving is the word some... I don't know how to spell that. I can spell it with my Arabic accent, but so yeah. Chronos, I think. But anyway, I have no idea what is wrong here. Let us try this again. Oh, it's talking about another guy. Gotcha. Well, yeah, it's talking about this guy. Yeah. Alright, hold on, let me see. Set index buffer, and you actually have to tell it .uint32. Okay. So instead of this, you have to tell it .uint32. I guess like that. We have an error, a runtime error. Invalid validation index range. First 0, count 3, format index does not fit in index buffer size 3. What? While encoding, render pass draw indexed. Render pass draw indexed. Ew, it should take in a type email. Index counts. And then this is the instance count, then this is the first index, then this is the base vertex. This is so weird. Time to rewrite it. Let me see what it's doing here. 3100000. 3 probably 1000. So that should be right. Isn't that a problem caused by the size of? Who knows? Possibly. I don't think though. But let me just try to basically hard code this. Oh, hold on a second, bro. What? Why have this draw? Let's remove that draw. Maybe that was messing up with the thing. Nope. Nope. Does not fit in index buffer size 3. Well, it's telling me that count 3 does not fit in size buffer index 3. Well, that's a weird error right there. But let me see what I've done there. We have index data, size of, type of index data, index, buffer, maybe size of -1. Hold on a second, really, hold on. I think maybe I know what's the problem. Hold on. Oh, it should start from index 0. Yeah. I programmed a lot in Lua nowadays. So that makes sense, okay. Since it's 0 based index. And it still doesn't work. Lovely. What's the problem now? Validation index range. Lookup resource, buffer offset, and T. Index buffer. What? Let me see how they're doing it exactly, honestly. So there is index buffer 3 times size of U32. Then you have the index data, It's sitting. Oh, what? Hold on. I think maybe I realize what's the problem again. And ZLS is not even helping. Yeah, it seems like I have to get the eb_info.size, basically the index buffer info.size. Maybe. Let's see. Yeah, I think it's in bytes, not length. Maybe. Let's try this out. And finally, we got the index buffer working. Let's go. But since that's the case though, isn't it the same thing maybe with this guy? I mean, can't I just say, oh, in fact, I'm already doing it. Yeah, I'm already doing it. Makes sense. All right. So we got the index buffer working. Amazing. Next up, I would like to add, I guess, MSAA, I think, which is basically multi-sampling. But before that though, let me try to figure out the math, because I still haven't looked into the math. I just copy pasted in the previous live stream pretty much. So let me try to figure out. Honestly, before that, I'd like to do something fun, which is to change the shader. Now, I don't really like the colors having a color per vertex, so I'm going to remove the vertex colors. I don't need it, honestly. Just so ugly. So I'm going to remove the color vertex attribute, and I'm going to show you also how to actually, what's the changes that are needed to do that. Well, at least hopefully we're going to try. Okay, let's see where it's describing the vertex stuff. There you go, vertex attributes. So I'm going to remove the color attribute stuff, and I don't need it in the struct. And yeah, I think that's maybe it. Maybe. I mean, let's try it out, I guess. Yeah, I think let's try it out. Okay, now one thing we have to change the vertex, the shader, sorry. So let's see. Of course, we do not have a color anymore. And in the vertex, of course. And here, vertex position clip color is equal to color. Now, for now at least, so color is Vic4 or what? Oh yeah, it's the Vic3, but in fact, I'm not getting a color. Oh, hold on a second. No. That's the vertex out, not the vertex input. Yeah, so let's leave that. Well, in fact, you do not really need, depends. So like if you want to basically set the color from the vertex and then basically pass it to the fragment, then you need this. Otherwise, you do not. But let us go step by step so I can show you all the solutions. So the actual real thing that we need to change right now to make this work is this guy, the input vertex stuff. So we do not have a location one color anymore. We only have position input. And now output, let us not change that for now, just so we can show you what we can do with that. So output the color is equal to, well, what is the color again? It's a Vic3 F32, okay. So Vic3. And then here I could basically, for example, white 1.0. And since it's a Vic3 and I'm giving it one parameter, I think if it's like GLSL, then it's probably going to basically make it X, Y, and Z. It's like I wrote 1.0, 1.0, just like that, basically. It's kind of like splat it, but anyways. So I guess let's try that out, I think. Let's see if that works. There you go. As you can see right now, it's white. Amazing. Lovely. White. Now, there is another solution. Since we only basically set in we're not using the vertex data to set the color of the fragment, then we don't even need to actually set it in the vertex itself. So we can remove this guy and we can remove it from the vertex output. And then basically we could, and right now we're not getting the color input anymore, I think, isn't it? Hold on. Yeah, I think so. And by the way, that's the location of the render target, basically the color target, which we only have one anyway for now. Vic4 color. Now we do not have a color coming up from the vertex anymore. We have to actually do it ourselves. So I could in fact basically make it white, for example. And let's see if that works out. If I didn't miss anything there. And there you go, it works. So right now, vertex shader doesn't have anything to do with color. Only the fragment shader is controlling that. Now, to be able to actually control the color of the triangle, I'd like to we need to basically expose a uniform, just like this uniform right here, basically. So I'm going to basically try it out. Let's see. Now, I never really understood bindings and groups yet, even in Vulkan, but we're just gonna try some stuff out. For now though, I think I'm probably going to say 1 for binding and just keep group 0. And here we can make it color, and it's not a matrix, it's just a Vic3. In fact, we could make it Vic4 if we want transparency too, but for now let's just start by a Vic3. Vic3, and of course it's F32. Okay, interestingly, now we need to pass that thing, that color. All right, well, let's figure it out. Binding. Okay, so there's this bind group handle. Create bind group, okay. And then we have binding 0, buffer handle, graphics context uniforms dot buffer. What? Oh, so I probably need to create another buffer, or what exactly? I don't know. Weird. Offset 0, size of math, zmath matrix. Okay, let me try to figure out how I can add that binding though. Binding equal 1. Dot buffer handle. I have no idea about this guy, but for now I'm just gonna set it the same thing as the one before it. I'll try to figure out how to make that work. The offset is equal to 0. Dot size is equal to, in our case, it's basically size of, maybe zmath could probably have that. Let's see, Vic3. There's any Vic3 there? Viclen. What? Vic2 array 4. Viclen. Vic. No idea. So I think I'm maybe just going to say the size of let's see, size of U32, and then basically I'm going to say 3 times size of U32, I guess. Invalid built-in function. Okay, it's like this. I'm just guessing this though. We'll see if that works or not. So yeah. And so that's the first thing that we have changed. Let's see if we can change something else. Okay, probably the next thing, maybe, let's see. So what that guy is called, hold on a second. What we called it, object to clip. Okay, let me find out about that. Ooh, and uniforms allocate. What is that? Uniforms. Gotta go. I'll watch this later. See ya. Goodbye. Okay. I guess that wasn't as simple as I thought, maybe. Let's see. Set bind group 0. Bind group mem dot offset. Ooh. Mem dot slice 0. Oh, here where it's actually putting that guy. Gotcha. Interesting. Uniforms allocate. Weird. I guess I'm just gonna try something though. Let's see. So maybe I'm gonna call this mem2 for now. Instead of zmath.math. Well, I don't know how to make a vic3. That's the big problem here. Honestly, I'm probably gonna ruin it. Probably gonna ruin it. I don't know. Let me see if we can have some other sample that shows us that. Let's see. Triangle textured quad. Honestly, I think we're not gonna do this yet. That is weird. I don't know how to do that yet. I think let us not waste time on that. Okay, I should have actually committed that. Where I am. Okay, so I think we were here, right? So I think right now I'm going to try MSAA. Okay, let's try to find out how to do MSAA. I think I've seen a sample around here somewhere for that. Triangle WGPU. Doesn't seem like it's right here. Weird. Weird. Let's try to find something about that. Triangle WGPU MSAA. Well, this is WebGPU using JavaScript, but I guess maybe we could figure it out from here, possibly. No idea. We'll see. So, well, sample is no longer. It shouldn't be very different, but you know. Yeah, resolve. We need that. Get current texture dot create view. Clear discard. Where is the MSAA stuff? Interesting. Okay, there is a multi-sample here though. Oh, in the pipeline. Alright, gotcha. In the pipeline I gotta make the multi-sample accounts for. Then after that, what is this texture right here though? Okay, I should create a texture, right? This is kind of unreadable, but I'm trying to figure it out. Size, canvas.width, canvas.height, okay. Then the sample count, the format, the presentation format, the usage, the render as a render attachment, right? We're basically creating another color attachment. Interesting. Then we're creating a view out of that. I think it's probably doable. I'm going to try this out. Okay, so dot multi-sample. Well. Where is the pipeline? So let's look for pipeline descriptor. There you go. Multi-sample is equal to dot count, I guess, is equal to 4 for now. Or let's actually say const multi-sample count. Multi-sample count 4 for now. And now we set that in the pipeline. Afterwards, we need to create a texture. So basically, you got to create another texture where you could basically resolve, I think, the MSAA thing. So basically, what happens in multi-sampling, for example, here count 4. I mean, I don't understand it fully, but at least from what I understand, is that it's going to render it like, I think 4 times the actual size of the resolution. Like, for example, if you're using the resolution full HD or HD, yeah, well, maybe full HD, then when you use multi-sample 4, maybe it would basically render in 4K, then kind of resolve it into full HD. At least that's what I kind of understood from using Vulkan, but it's probably not very accurate, but we'll see. Either way, that's kind of the general concept, the underlying concept. So yeah, so let's try to do this. So first of all, I need to create a texture. So let's figure out how to create a texture. So where they're creating a texture before the frame, I think, after the pipeline, basically. So I'm going to create it before the, I think, the bind group stuff, etc. Okay, after creating the render pipeline, and then I'm going to try to do this now. Const texture. It may be different though from this guy, but we'll see. Okay, so graphics context maybe .device .create texture. There you go, nice. We already got the device. Now we need the texture descriptor. Okay, nice. Now what we need, I believe, maybe the size. Doesn't seem like. Well, let us see the actual thing. Hold on. Create texture, texture descriptor. And there you go. This is all the stuff that is possible. There is usage, dimension, and size. Well, there is size, and there's format. MIP level, sample count. Ooh, okay. View format count and view formats. Interesting. Hello, whoa, GJ Gearing. Welcome to the live stream. So, texture dimension, TDIM2D. What? Texture usage. Okay. Well, I guess let's try it out. The size is equal to, but what is that? Hold on. What is that? Is that an array or what exactly? I don't remember. Let me actually try to basically pin this guy so it doesn't close. Okay, interesting. So it's extent 3D. Extent 3D, which is basically a width and height and a depth or array layers. Nice. So okay, it's a struct basically. So equal to, I guess, dot width. So ZLS is not helping me here, so I'm trying to wing it. So dot width is equal to what? By the way, let me add the multi and trailing comma there, I guess, so it formats it better. Hold on. That's kind of annoying me. There you go. Okay, that's much better. Okay. So dot width is equal to what? Maybe I could get that from the swap chain. Swap chain descriptor. There you go. Dot width. Nice. Nice, nice, nice. Dot height is equal to graphics context dot swap chain descriptor. Dot height. And then there's also the format, I believe. Right? Isn't it? There you go. Yeah. So I could probably get that too from the swap chain. descriptor. Yeah. And let's see what else we need. Size, format, usage. We probably need also the usage. And maybe the sample count, I don't know about that. Let's see the texture usage. In our case, it needs to be a render attachment. So, okay. Dot usage is equal to dot render attachment is equal to true. Oopsies. Hold on a second. Let me format it well by adding a trailing comma there. Okay, amazing. I think that's probably all we need, maybe. Oh, by the way, hold on a second. This should be here, actually. Yeah, maybe. Maybe. Let's just see if we get any compile error or something. It seems to be compiling, I guess. But there is a problem, though. Yeah, because, yeah, we still didn't actually end that guy. But basically, attachment state of render pipeline is not compatible with render pass encoder. Yeah, makes sense. Expects an attachment state of sample count 1 has an attachment state of. Okay, interesting. Yeah, that's what we're trying to do here. So we have, I think we have created the texture right now that we need. But I think we also need to create the view, right? Const view is equal to texture dot create view. There you go. And then we need the descriptor. I guess we could leave it as default, maybe. I mean, let me find out what it needs. Label format in the find. I don't know. Maybe I need to set the format and stuff here. I don't know. We'll see how it goes. For now, I'm just gonna keep it like that. Okay. What's next? What's next? So in the render pass descriptor, I need to pass in the view, yeah, which is my texture right here, and then I gotta resolve it into my, so interesting. So I'm gonna call this multi-sampling or multi-sample texture, I guess. Well, anyway, I'm gonna call it multi-sample texture. And then basically call this multi-sample texture view. Okay. Don't I need to set maybe the, hold on a second. No, we only have set to these. Oh, sample count. I think I didn't do that. So let me try to figure out sample count. Oh yeah, I missed that. Okay. Sample count is equal to sample. There you go, multi-sample count. Interesting. Hopefully that would work out. Now basically you need to render into, where is the render pass? If I understand correctly, instead of rendering into the current texture view, I'm going to render basically to the multi-sample texture view, and then I guess resolve it into, but there is no resolve here, so I guess probably I need to actually use the advanced version. Yeah, probably. Begin render pass color attachments. It seems like, well, I wasn't ready for that. Well, create render pipeline simple. Interesting. So I basically need this stuff right now, I think. So where it's actually putting that in the color attachments. Where is the color attachments here? There you go. This is the one. And yeah, indeed this have a resolve target. but I think in here it's not using it. Begin render pass. Where's that guy? There you go. It's not using it, as you can see. Well, I gotta code this myself now. Let's just get this. Luckily, it's not that hard. So yeah. But okay, let me try to figure this out. So I'm just gonna comment this out for now. And let's try to make this work. Yeah, so basically this is our render pass encoder. So right now we can't use that begin render pass simple function because we're using a resolve target for MSAA multi-sampling. So here it should be zig-gpu.wgpu, and then here the color texture in our case is the, well, in our case it's actually right now, it was the other guy, but now it should be multi-sample texture view. So we should render into the multi-sample texture view. The Lloyd operation. The Lloyd operation is, I believe, clear. Let's see. Yeah, clear, and then store op discard dot clear. But here, notice that we shouldn't store it. I mean, we can store it, but that's not good because we do not need it. We're going to actually resolve it into the actual frame buffer, the actual swap chain frame buffer. So this is kind of like, you know, basically how I understand it is that this multi-sampled frame buffer, or a texture, sorry, is kind of like temporary target, draw target, and then basically we're going to resolve it into the actual swap chain. WebGPU has higher performance than WebGL. Well, in terms of GPU performance, it's pretty much the same. It should be the same. Well, actually depends. I mean, the only problem with web is kind of it's limited because there's a lot of constraints. For example, you cannot accept undefined behavior in web. At least that's how I understood it. So they have to do some extra stuff probably to protect the GPU, because you cannot afford to crash when you're programming in the browser. But in native, which is basically WebGPU in this, oh, you're actually talking about WebGPU versus WebGL. No, WebGPU has a much higher performance than WebGL. I thought you were trying to I thought you were asking about WebGPU versus GPU of the web, basically. So native versus web, because you could use WebGPU in web and native. In my case, I'm using it natively, you know, so using Dawn. But anyway, so here now, instead of dot store like what we had before, I have to use dot discard, right? Yep. Why using Zig instead of Rust? Hold on. Let me just do this. Hold on a second. Discard, yeah, it's called discard. So you asked why using Zig instead of Rust. I personally enjoy Zig much more for such low-level projects. No, I never said Rusty's did, but basically, the thing is, for my type of projects, my hobbyist projects that I'm using, you know, low-level stuff, and it's pretty unsafe, and I cannot afford to stay fighting with the borrow checker every time I do something, especially in such an unsafe environment. Like, I'm doing all sorts of unsafe stuff. So Rust is just not for me. I enjoy Zig much more because I do not have to fight with the borrow checker. I mean, I would use Rust if I was, like, let's say, programming some software for an airplane, or you know, or for a medical device or whatever, where safety is really needed. But I honestly, so far that I used Rust, I found myself wasting a lot of time with the borrow checker. And in fact, the undefined behavior and the stuff that the borrow checker protects me from, it doesn't even worth it, at least in my case. It's pretty easy to find undefined behavior or or bugs. I mean, at least in Zig. Not C++ and C. C and C++ is kind of a different story in that case. But for Zig, it's pretty much. But the bottom line, though, I enjoy Rust. I enjoy Zig for such projects, for low-level graphics programming. But anyway, so let me try to figure this out. Clear value. If clear colored, else do this. Okay. So what does the clear color? Oh yeah, the clear color is. Let us see. I'm going to say this, and then I already have a color. I think. Yeah, there you go. 0. Color 1, color 2, and here I'm going to keep this as 0, I think, probably, for now at least. I do not need any depth texture currently, so we can get rid of this. And we're out with this guy. Begin render pass. But of course, I do need resolve. But hold on. So yeah, resolve target. It's called resolve target. Interesting. The resolve target is equal to what? To our current texture view, right? To the swap chain texture view. Where is it? What? Where is it? Okay, there you go. Current texture view. Okay. Current texture view. I should probably call it a much more descriptive name. But anyway, so begin render pass, and then you give it the count and then the color attachments. I think that's probably all we need, if I'm not mistaken. Let's see. Let's find out. I hope it would work from the start. Let's see. I mean, I think it's compiled, and there you go. We have a runtime error for whatever reason. Okay. Attachment state of render pipeline is not compatible with render passing coder. Expects an attachment state of colored formats. Oh, I think maybe I know what's the problem. I probably need to set the thing. Hold on. Clear. Create texture, create view, resolve target, load OP, store OP, begin render pass. Weird. Begin render pass. Let me have a look here real quick. Oops, not this. Where I am. Render pass descriptor. What? Well, it's only in texture descriptor. I'm not really sure. I think I need to set the sample count somewhere else, but I can't really figure out where. I mean, let me make sure I've done that. Where is it? Ooh, what's this? Color. Oh my god, I'm actually. Hopefully, I didn't edit the this guy. Hold on. Hopefully, I didn't. Well. Okay, I should be in here. Where is the texture? Create texture size. I set the sample count here to multi-sample count, and also in the pipeline I've done the same thing. Nice, but what's the problem? Has an attachment state of color formats. Sample count for. Validation attachment state of render pipeline is not compatible with render passing coder. Render passing coder expects an attachment state of color formats. Sample count 4. render pipeline, what? Has an attachment state of color formats, texture format, sample count. Okay, so it's telling me that the render pipeline has a attachment state of sample count 1. What? Where's the render pipeline? I mean, that's the descriptor. I already set the multi-sample count to 4, so what's the problem? Did I miss something? No, there's only count 4 there. Where it's using sample count though? It's only using in texture, so I have no idea what they're talking about. Clear, discard, resolve. Begin render pass. Oh, maybe I should set the sample count in the view. Hold on a second. If I go here, create view, maybe that's the problem. No, it doesn't have even that. In fact, dimension format. And in fact, all of this stuff in defined for whatever reason. Weird. But I could check out something real quick, which is where is it? Where are there you go. Here's the samples. Let me see the textured quad WGPU, for example, and let's find out. Maybe I'm missing something. There you go, it's creating the texture. Okay, usage texture binding, and copy that DST size, image info to texture format, MIP level count, create texture. How to make diagram in VS Code. What do you mean by diagram? Which diagram? Create texture view. By the way, do I really need? Oh no, I don't. Okay. Create texture view. Graphics context. Oh, what? Texture. Image data. Bind group. Generate map maps. Create command encoder null. Weird. Bruh, come on. Store OP back buffer view. I can't figure it out at this point. So expect an attachment state of this guy, which is right, but the render pipeline has an attachment state of color format sample count 1. Let me try to figure this out. Render pipeline. Set pipeline. Create render pipeline, pipeline layout, and then the multiply. Shader module, fragment, vertex layout label. I mean, there is nothing there. Oh, well, hold on a second though. There's dot targets equal color targets, and what? Oh my. Well, hold on a second though. I think I got it, maybe. Color attachments. View. So maybe I need to say that sample count here. Dot samples equal. What is it called? Multi-sample count. What? Why? Hold on, let me see. Use of undeclared identifier. Oh yeah, it's actually declared here. Interesting. Okay, let's try that out. And something is wrong. No field name samples. The ZLS is going crazy on me. Oh yeah, that's not the case. It doesn't have that. Color target state. They have a texture format, a blend state, and a right mask, and that's really not relevant. Huh? Dot fragment color targets. Weird. Swap chain. Can we look for another example though? WGPU MSAA. Let's see. Can set. Let's see WGPU there. Oh, this is from 2021. Well, I guess there you go. Hold on, let me see this one. That's not from an official source. Hold on. WGPU GitHub. Let me see if I can find some examples there that I could maybe understand from it. There's MSAA line. Well, let's figure it out. SRC main.rs. They're calling it multi-sampled frame buffer. Interesting. They have a descriptor here. MIP level count, render attachment, and the sample count here. They're creating a texture, then they're creating a view. Okay. There you go, they're resolving into some view. Clear. Begin render pass. RPass color attachment. RPass color attachment. Okay. Okay, let's go to begin render pass, I guess. Bruh, come on. Else WGPU. Can I read the error again? Render pipeline. Okay, let me have a look into the pipeline that they're making. Create render pipeline. I mean, exactly what I was doing, I guess. They're using the render bundle though. Create multi-sampled frame buffer. Create bundle. And here they're passing sample counts. What? The render pipeline is not compatible. Expects an attachment states of color formats. Sample count 4. And then the render pipeline has an attachment state of sample count 1. Bruh. While encoding the set pipeline. I don't think the problem is with the render pass. Not that. Begin render pass, that takes in the render pass descriptor. And the only relevant thing from all of this is color attachments. Now that takes render pass color attachment. Load OP, store OP. Well, I guess maybe let's experiment a bit. Alright. Render pass color attachment. Now what would happen if I just set the current texture view here and then I resolved that there? It doesn't make any sense, but let's just see what's gonna happen. Okay, cannot set texture view as a resolved target in the color attachment. Texture view a texture of swap chain, there's a sample count of 1. Yeah. So totally, while validating color attachment 0. Yes, so at least the texture view right now we're sure that it's actually right. Resolve target current texture view. Begin render pass. What this function does, it uses WGPU. And is there like some other version of this guy or what? Begin render pass, that's only version. I think clear buffer. Yeah, I mean, bruh, come on. Duh. Maybe I'm missing out on something here. I guess let me try another example, try to figure it out, which is the volcano example. Let's see. I do remember I kind of understood it from there, honestly, but let's see. And in fact, there's also a tutorial about multi-sampling for Vulkan, well. But yeah. Supported features, but let me just try to, okay, transient multi-sampled. Interesting. It's called intermediary. This is Vulkan. So Lloyd clear. Okay, well there is 2 attachments here though. I'm not sure. So this is in creating the render pass. It have 2 attachments. You have the intermediary and the color. Render pass. I wonder if that's the case. I mean, in the other examples of WGPU or WebGPU, it didn't have that. So maybe it's different. Well, I guess let's try to go with the logic of Vulkan and hope it would work. So the render pass, where we're creating the render pass, I think it's called the, well, where hold on. Not the pipeline, right? The render pass. Okay, interesting. So this is the render pass, and this is the actual color attachments. And maybe we have to have an intermediary, isn't it? Okay, let's try that out. So the first one is the, what? That's kind of different, I guess. Hold on. Multi-sample texture view. Where's the resolve though? when we're drawing, we have only one output, which is the intermediary image. Resolve color. I think it's probably merged in one struct. It's not like Vulkan, I think. Probably. But doesn't this have dot samples? I don't understand this. Nope. Well, what about... Hold on, what about this guy? Begin render pass. No, this also doesn't have such a thing. Honestly, I have no idea at this point. This is so stupid. I think the texture, we have created it right. Now it's either the render pass or the pipeline. For the pipeline, there's nothing really interesting, honestly. Like fragment targets, topology, multi-sample. I think the pipeline we have created it right. I think we have the problem somehow in the render pass. I think. So, hello Blue, welcome to the live stream. Kind of stuck here. Command encoder.finish. Okay, well, let me just copy this over so I have an easier time trying to... Can I too hear your thoughts about Rust? What do you mean your thoughts about Rust? Const. Hold on. View, multi-sample texture view. We got the resolve target here, which is pointing to the actual current texture view. You got, of course, the clear value. The load OP is clear and this card is store OP. I have no idea at this point, like, what's the problem with this guy. That is so stupid. I don't think I'm missing anything. Oh, well, I mean, let me try something. I mean, set... Let's see, what is we can set here? No, there's none. Nothing interesting here. Well, all right. Well. That seems like a big failure. Hold on a second. Maybe I could, like, is ZGY using multi-sampling? Maybe. I don't think. No, it's actually linked in. So in the chat history, someone wrote that Rust is dead. I wasn't know that. So no. So my thoughts about Rust is that it's not for such hobbyist projects. I would basically use Rust for projects like, for example, I guess airplane software, you know, or for example, secure servers that would, or for example, let's see, medical equipment, or, you know, something that needs that safety, you know, like basically fighting with the borrow checker and trying to figure out what's the borrow checker is trying to say, and etc. It takes a lot of time. And especially with such things that I'm doing, which is inherently in safe, graphics programming is basically in safe. It's all in safe, so you pretty much waste a lot of time trying to figure out what's the borrow checker is trying to say. So basically, it just doesn't worth it for such hobbyist projects. The safety that Rust gave you, because that safety comes with a big cost of your time. So yeah, GUI.render. So I couldn't figure it out, honestly. For some reason it doesn't work out. Do you think Rust is good for embedded systems, or maybe Zig is better? Well, depending on which embedded systems you're talking about. Like, if you're talking about an embedded system that cannot accept the cost of failure, then sure, Rust may be worth it. But for the games, for example, you know, safety doesn't really worth a lot, you know. I mean, when you get to indefined behavior, you could probably easily find it using a debugger or something, pretty much. And like trying to fix bugs because you do not have a borrow checker is probably much easier and faster than trying to like always trying to keep up with the borrow checker at every step. And it also doesn't allow you to. So every time you want to even add a function or a new class or a new abstraction, you think like, bruh, come on, the borrow checker will go crazy on me again. So no, I'm just gonna do it in here, you know. It's like, I'm not gonna do that. But yeah, so it just doesn't worth it for me currently, for my own projects, of course. So yeah, pretty much. I honestly have no idea what. I like to learn different programming languages, looking for new languages. You think Rust is worth to look out? Rust is a pretty cool language, let me tell you that. But if you're going with low-level stuff, low-level programming like I'm doing, and like graphics programming, engine programming, etc., I do not recommend starting with Rust. Or Zig should be better or different. Zig is much better for in-safe code, you know. Much better. I mean, I'm not saying that Zig is not good for safe code too, but I'm just saying that Rust is much better when you're dealing with safe code, especially if you have already a library that can do that for you. For example, if you're creating a server in Rust, you're probably gonna have you probably want to do it in Rust if you're working on a server, you know, a production server, because it may be more secure and much more suited for such an environment. But if you're making, for example, a game engine or something like that, then I just don't see it worth it, you know. Like, you just spend a lot of time trying to figure out what's the borrow checker is trying to force on you. So yeah, I use JavaScript, WebGPU, and make a game. JavaScript, I never really gone deep into JavaScript, honestly. But yeah, honestly, I think at this point this is just so wild. I guess maybe I'm just gonna take a little break and then come back. What do you think? Or we should just try something else? What do you think? Should I just take a break and try to figure out again what's going wrong with this stupid thing? Or the thing is, I mean, hold on, maybe I could find it in some other sample. Like, because I just don't get it. Like, I think I'm setting that right. I just don't understand where the error is coming from. Let's see WGPU. All the stuff about WGPU. Okay, GUI test layers, physically based rendering, physics test, textured quad. I'm trying to find something that uses that guy, that uses samples, multi-sampling. Well, for example, physically based rendering. It's probably using that, isn't it? Let me see. Let me see. src. Hopefully it's a one file. Physical. Why there's two? Weird. Oh. Oh yeah, so this file basically contains all the shaders. Interesting. And here, this is the actual code. Amazing. Oh my god, that's very large. But let me see if he's using samples here. No, it doesn't seem like. He's not using multi-sampling here. I'm trying to find the example where they're using multi-sampling. Weird. Hold on, maybe I could look for some C++ guide. Hold on. If you guys have any suggestion, let me know. WebGPU. Hold on, maybe there is multi-sampling. Ooh, but this is a to-do. Oh my god. Well, that's a to-do. Interesting. Well, C++ WebGPU, let's say multi-sampling. I'm just trying to find any example, bro. Like what? Implements multi-sampling TLAC. Native examples and demos. Ooh, okay. Hopefully that would help us. I mean, it should be the same thing, just the syntax is different, but let's see. I never really tried C++ before. I mean, with WebGPU. So we'll try to see what they're doing here. MSAA sample counts. That's the frame descript, multi-sampled frame description. Okay, they're giving it the sample count. The multi-sample state. Ooh, well, hold on, what the? Why the multi-sample state is 1? Are you kidding? Oh, what? Bro, there is 2 rendering pipelines, why? Oh, maybe he's trying to show off, like, maybe he's kind of switching between them at runtime, I guess. Yeah, so probably, yeah, probably. So yeah, the sample count equal MSAA, okay. So MSAA sample count, multi-sample state. Well, that is super weird. Okay, let me try to figure out where the problem is. I'm going to put the code here for a second. Let me give it another chance. Let's start from the start. So let's start by creating the texture. And let's see how they're doing it. Okay, where is my texture? Where is my stupid texture? There you go. So what he's doing there, he's setting the label, no need. Size dot width, GPU context surface dot width. I'm using the swap chain descriptor, so I think it's probably the same thing. That doesn't probably matter. Depth or erase layers, it's already 1 by default. Format, yeah, sure, he's setting that. The multi-sample count, he's setting that. The dimension, yeah. And usage is render attachment, yes. And then he's creating a texture view, right? Well, first of all, he's creating the actual texture, right? And then he's creating the view. Okay, here I am creating it. I think this is probably the default values. Although honestly the format, hold on a second. I think the format was indefined or something. Graphics context dot swap chain format, and the dimension is probably good by default. Map level count, array count, layers, that's probably default stuff. Let me just make sure to build this. And at that point I think I made sure that this one is probably correct. And now let me verify the other stuff. So let's see where we're set up in the render pass, I guess. Okay, I have begin render pass here. So color attachment, depth attachment, and render pass descriptor. Assigned later, resolve target and view. So there is clear and store. What do you mean by store? I have clear and discard here. Clear value, we said that those guys are gonna be assigned later. Color attachments. Okay, let's see where he's using the setup render pass function. He's using it here. Weird. Well, where he's setting the view, or let's say resolve target. There you go. Build command buffer. So if you use MSAA, he's setting the view to multi-sample target dot color dot view. I mean, that's what I'm doing, I guess. Resolve target is equal to the swap chain frame buffer. I think that's what I'm doing. There you go. Current texture view. Alright. Then he's creating the command encoder. Then he's beginning the render pass. Well, if you use MSAA, he's using this pipeline. It's called rpass, well, pipelines.msaa, which I've already looked into, I guess. And then he's basically setting the bind group. He's drawing the model. Then he's ending the thing. Then draw UI. Per frame. I mean, that seems to be fine to me, but now the only thing that I can think of is possibly the pipeline. Okay. The rendering pipeline. I think I've already checked this one though. Normal non-MSAA rendering pipeline. I don't know if this is a bug or a skill issue. No idea, honestly. Like, I checked this stuff thousands of times. I just don't see a problem with it. Imagine that it's not my problem. And it's actually just... By the way, what is this stupid mask stuff? No idea. Multi-sample state. But in fact, I think it's only setting... Yeah, it's only setting sample count here. But I don't know what this mask thing is. Probably not relevant. Alpha to coverage enabled. So the mask said to be full. No idea. Honestly, at this point, I think... I mean, I tried everything. I checked everything. And it doesn't seem to be any stupid mistake. Like, what? What? So I think I'm going back, honestly. Maybe I'm going to try this further in off camera or whichever, but yeah, that just doesn't seem to work out, honestly. That just doesn't seem to work. Any suggestion though for what to do now? Honestly, I'm kind of tired right now. We basically checked everything and I just couldn't find a mistake. That makes total sense. We even checked some Vulkan examples and no luck. Multi-sample texture. Like, currently I genuinely... I'm thinking, is it really my own problem or is it some bug in the binding or in the actual implementation? I don't think it's... I don't know, man. I don't know. No idea. This is so weird. Texture. So let me go back. I should have probably used Git before doing this stuff. But anyways. Oh, so yeah, okay. Alright, so this is the place where we actually have decided to try that out. Okay. Oh well, that was a lot. Okay, so that was it. I think at this point I'm probably going to end this stream. Since I'm very, very tired. Unless if you guys have any idea, let me know. Look at LH. So the eye position, the focus position, the up direction. What we have done so far though, I don't think much. We basically made that shader source thing. Okay. No idea, but maybe we can search for other examples. I mean, I've checked multiple examples and I mean, That's the exact same thing I was doing. It's right there. I just don't get it at all. Like, really, it's so weird. But maybe we could do something, which is to basically start the project, like another project, a second project, and try on an empty slate, basically, without all of the noise. That's probably would have been a better idea, honestly, to test that in isolation, because maybe because there's a lot of moving parts, basically. Yeah, I guess that's what I'm going to do now, and just try to figure it out. What GPU brand are you using? I'm using NVIDIA GeForce GTX 1650. But yeah. But anyway, I'm going to say rotating triangle. I'm just going to commit this into GitHub and sage all changes, commit, and sync changes. Okay, so right now if you check out the GitHub repo, you're gonna find the changes that we have done today. Right now, I think what I'm going to try to do real quick is to try to set up a little side project and try to figure out why that, like, try to, well, I don't know how much it would take though, honestly. That's gonna be weird. But maybe I could do something. Hold on a second. Pass the link. Oh, try hard, make a single triangle. Hold on a second. Here's the link. Well, where is it? Where is it? Where is it? There you go. Because that's just I'm dying right now to know why that didn't work. Weird. Anyway, well, we wasted a lot of time on that. But here's the link of the repo, and if you look into the commits, you're gonna find a lot of all of the stages that we had to go through. Hold on, 6 commits. There you go. And basically we have rendering. So we started with rendering, then animated colored windows, ZGY color picker, triangle, licenses, and readme, and then rotating triangle here. And this, here's what I'm probably going to do right now to test that in isolation. Here's what I'm going to do. I'm going to basically clone this repo, right? And then kind of go back to where I had nothing, just, you know, just rendering nothing, and try to go from there and see if that would work. Yeah, that's what I'm going to do. Okay, all right. And that's also a good thing. Why? Because I can show you how you can actually do that for yourself for whatever reason. So, all right, I'm going to close this for a second. Okay, well, git clone. Kind of tired at this point, but well, let's just try this out and see. So first of all, we need to clone the repo. Okay, git clone, or in fact, we could basically say, click on this, clone git repository, and then I think clone from GitHub. Then you could basically say Codotaku, but let me show you how you do it in the command line though. Git clone, and then you pass in the link. And then it would clone it inside of the current directory. Then I can go inside of it. Okay, now I could basically say code point to launch VS Code on that directory. And then right now what I'm going to do, I'm actually going to check out to that commit. So I think I have a good extension for that, honestly. Let me see. Okay, there's a commit graph here. Then maybe I could say this and then check out. Is there a checkout button here? Switch to commit, I guess. I think it did. Let me see. Let me see if that worked. There you go. Amazing. Amazing. All right. So right now, as you can see, we're back into that thing. So if I say zig build run, what? File not found. Oh, I didn't. Yeah, I forgot to actually clone the sub modules. My bad. Okay, I also should add that to the README actually. But anyway, I always forget about this command, but basically it's init submodules recursively. I always forget about this module. So, I mean this command. But anyway, you just do this, and that would basically go ahead and initialize and update the Git submodules. It's taking some time. I mean, zig-gamedev, right? It's quite big though, because it contains multiple projects and some samples. But yeah, pretty interesting stuff. Okay. It's taking quite some time though. Ooh. Okay, I think it's worked now. Nice. So let's actually try it now. Zig build run. And it seems to be compiling. There you go. We're back into just a window. We're not rendering anything. We're just rendering nothing. So, okay, now this is a good test ground to try that out. In fact, I should have probably gone maybe to the render pass though. Hold on a second. PowerShell. No, I want to the git lens, I guess. Commit graph. There's an animated color window. I actually probably would go honestly with this one instead, in fact. Maybe let me try this one. Switch to commit. To commit. Yeah. And there you go. There you go. Okay. So this is what I really wanted. So this was the colored window. There you go. All right, interesting. That's what I wanted. Nice. Now I'm basically first of all going to actually turn this. First of all, I'm going to get rid of that stupid animations. G and B. Okay. Now I'm basically going to inline this function. And I don't know why it's not letting me. Lets me restart ZLS. And hopefully that works now. Okay, there you go. Okay, nice. So I'm just going to inline this function call. Grab this guy. And put it here. Okay, so I don't need depth texture stuff now. If depth texture, no, I don't need that stuff. And we're down to this code, and this basically goes into here, right? But let me just say, in fact, let me comment this out, and let me just say const render pass encoder is equal to this guy. Okay, now color text v in this case, well, WGPU, yeah, that should be zig-GPU, right? And then here color text v. In our case, it's color current texture view. The Lloyd operation is basically clear, and the store OP is store. Now we have a clear color, so we're gonna use that, which is in this guy. Although I wonder if the clear value has some sort of a default value. Well, no, not really. But oh well. Anyway, let's just keep that. And what else? Pretty much that's it. Okay. So it should be the same exact thing. We have just inlined that function call manually. Yeah, seems to be fine. All right, now let's actually try out that craziness. Okay. First of all, let's start by creating a texture. So const texture is equal to graphics context dot device dot create texture. Okay. Now here we have texture descriptor. Hopefully it would work this time. Otherwise, bruh. Oh man, we'll see. Okay. Create texture. Texture descriptor. Let's go. So this is all the stuff that we could actually put there. Let me just comment this out. So we could basically put. Let's start by .usage. Oops. Well, this is annoying. Let me actually get it out of here. Okay, so .usage is equal to, it's I'm having troubles compiling zig-GPU. The problem seems to be with Dawn. Do I need additional dependencies like system libs or something? You can actually share that with me on Discord, and I'll let you know if I can figure it out. You can join Discord. You'll probably find the link for Discord in the description. So usage, it's a texture usage, and I'm probably gonna get it from the graphics context dot surface, maybe. No, not surface dot swap chain descriptor, right? Dot not format dot usage, I think. Yeah, I guess. I guess. And then other than that, you got probably the format. Hold on. Can't create texture. Well, I already got it here. Okay. So we got the usage, then we got the dimension, which is fine as the default value. We got the size, we could probably take from the swap chain descriptor well, in fact, I need to do it this way somehow. So dot width is equal to graphics context dot swap chain descriptor dot width dot height is equal to graphics context dot swap chain descriptor dot height, and that's pretty much it for the size. Next up, we got the format, which we're gonna get it from the graphics context. dot swap chain descriptor dot format. Let's go. Map level count equal 1. Sample count. Now the sample count here, sample count, I'm going to call it, going to give it 4, and then view format count. What do you even mean by that? Well, I don't think I need view format, so yeah, and that's that one. Now I just gotta create a texture view, I think, out of that texture. So that's multi-sampled frame buffer. Or, well, let's call it texture though. Now let's grab a multi-sample texture view, and then multi-sample texture dot create view. Okay, then here the descriptor, which we're gonna leave as default, probably. So that should work. Do I maybe need to actually destroy the texture? By the way, I don't know. Well, actually, let's first of all find out if this actually compiles even. Okay, seems like it's compiling. And let me try one little thing though. Defer multi-sample texture dot destroy, I guess, or release. Not sure what's the difference though between release and destroy. Hold on. Release versus destroy. Bro, what? Destroy the associated native resources as soon as possible. Okay, what about release? What? There's no release function or what? Doesn't seem like. No, there's no well, I guess I'm gonna use destroy. In fact, he's using release here. Yeah, I'm gonna go with release. I don't know what's the difference, but anyway, let's try this out real quick. Maybe release just write 0 on the data in memory. Possibly. Okay. Okay. So now we got the texture ready, hopefully. What's next? Did we get a pipeline? No. Yeah, we need to create the pipeline now. The problem, we do not have shaders. Oh man. Okay. Well. Let's try to create a pipeline. And by the way, one little thing that I kind of learned is the fact that you need to create the pipelines as soon as possible, because as I understand is that maybe, at least from what I understand, is that they get compiled in a background thread, you know. So you need to create them as soon as possible. So while they're compiling, you're actually doing some other stuff like creating textures, you know, doing meshes, etc., whatever. So I'm going to try to create them as soon as possible. That's just an optimization. Although I'm not sure really if that's the case, but anyways, we'll see. So cost graphics pipeline, well, render pipeline, okay, is equal to I guess graphics context dot create pipeline. There you go, creates render pipeline, and in fact it needs the pipeline layout. And and that's not optional. Okay, pipeline layout, so I need to do that. And then we got the descriptor. Now let's try to create the pipeline layout first of all. And I hope I don't have to actually create the bind groups, etc. to be able to do this. Okay, graphics context dot create pipeline layout, and then here the bind group layouts. Well, if I remember, it wouldn't let me. I probably need to create the bind layout, which is so stupid. I have no idea why that's the case. But anyways, okay, let's see what it's gonna tell us. Let's just see the errors. Alright, create pipeline layout, expected type bind group layout, find type of what? Create pipeline layout. Bind group layout handle. Oh well. Yeah, in fact it needs a slice, not a struct, I think. Missing struct field vertex in here. Okay, so I guess I need to set the vertex shader, although I don't need it. Weird. Vertex state. Yeah, so that's not optional. What about the fragment? Is it optional? It seems like. Oh, that's just the vertex state, not... Well, in fact, let's see what we got here. It needs a module. Oh, well, let's actually see. Let's just see. So there you go. I added a vertex. Let's see what it's gonna ask for next. So missing entry point. Well, I guess we gotta give it an entry point. Okay. Entry point main. And now I think it's asking for module. Okay, so I gotta actually create a module. So يرحمك الله يهديك الله ويصلح بالك. Okay, well, the module is equal to where is it? zig-GPU or what? I forgot. Graphics context, create pipeline. No, create module. No. What? All right. Well, let me actually see my own thing. Let me see GitHub. Codotaku. What did I call it again? WGPU, okay. src main.zig. Okay, so where are we creating the module? zig-GPU, okay. WSL shader module. Here the device. Well, Yeah, I guess. Yep, graphics context. Well, can't maybe I can actually use, hold on a second, graphics context.device.create shader module. There you go. And then the descriptor. Let's see what it's gonna tell us right now. There you go, got a runtime error. And it's telling us that bind group layout's length needs to be greater than 0. So we need to set a bind group. Find this very weird. I do not have any buffers to set a bind group or whatever. But anyway, create pipeline layout. Now let's actually see what it needs. Actually, this is what it's doing, by the way. Add resource. By the way, one thing, it could be that the binding is actually trying to force that on us. Yeah, maybe. Maybe it's not really the actual thing. Maybe it's just the binding itself. Ooh, well, interestingly. Hold on. I have a little idea. WGPU C++ guide that we have seen before. I didn't check this yet, but let me just have a look real quick. The device, the command queue, first color. Okay, let's go with the first color, I guess. Ooh, that is actually interesting, man. I should look into this guy. I should look into that. Anyway, dot usage, swap chain, image description. Is there like a GitHub repo for this or something? Color attachment. What about the binding groups? Well, it's probably not here. Hello triangle, probably. There you go. Yeah, nice. Vertex pipeline state. Okay, is it talking about the binding? Boom dom. Bind. There's no binding group. Weird. Ooh, what? But no, it's just multi-sample count 1. Weird. Well, that doesn't seem so great. I think honestly at this point I'm probably gonna stop and just try to... I'm kind of tired at this point, I think, so yeah. What's next? Shader uniforms. Yeah, that's very weird. So honestly, I think at this point I'm just going to stop the live stream. That wasn't so great, but anyways, that was it for this live stream, and see you later. Goodbye, everyone. Thank you for tuning in.